we need to calculate the Fibonacci numbers, or we need to, find the formulas. Find the formula. For Fibonacci numbers. Yeah. And here we need to start with golden ratio concept, because in the formula, we need to use the golden ratio in that formula. So you can see, some very special thing, the golden ratio. Yeah. Most of you heard of that golden ratio. Yeah. So let's look at that, here, so the golden ratio, so you can see, so not golden ratio. Here, the Fibonacci number, look at this, 1, 1, 2, 3, 5, 8. Are they Fibonacci numbers? Yeah. They are first few Fibonacci numbers. Yeah. We just skipped 0. Yeah. We do not include the 0. Yeah. So when you draw squares, 1 corresponds to f of 1. The second one corresponds to f of 2. F of 2 also equals to 1. Yeah. So you put a square with side 1 back to back with alignment. Yeah. Then the next Fibonacci number 2, you can see you can align well with the first 2 squares. And after that, square with side next to Fibonacci number, that's 3, you can align well with the previous few squares with sides as Fibonacci numbers. You keep doing like that, so you can get a rectangle. Yeah, you can get a nice rectangle. The interesting property from this rectangle, if you draw a quarter arc, yeah, so an arc, 90-degree quarter arc, yeah, quarter circle, yeah, it's a quarter of the circle, okay? Whole circle, you just take 1/4, that arc, yeah. For each square, you draw that arc, so you connect them, so you can get a nice spiral curve, yeah, nice curve, and you can find that kind of curve in the Mona Lisa painting, yeah, in this way, okay? Yeah, so some pretty interesting property, yeah. And that one also related to the golden ratio number here, okay? All right, yeah. So here, yeah, I still have a few minutes. Let me derive this golden ratio first. Yeah. So how to define a golden ratio? Yeah, we use line segment. Yeah. When we start, we use 2 line segments, one longer, one shorter. The longer one is A, shorter one is B. Yeah. Then we put it together to form A plus B line segment. Yeah. Then we require this condition, the ratio condition. A over B equals A plus B over A. Yeah. So that's the, ratio. Yeah. So why people assume this is assumption? Why people make this assumption? Yeah. Yeah. Because those people, they feel this is some natural way to connect these line segments, some beautiful way. So ancient people, they feel this is a beautiful way to connect these line segments, okay? Yeah. Then we try to find the ratio A over B. What's the ratio A over B? Yeah. So after we simplify this A plus B over A, we get expression 1 plus B over A. B over A. Okay, yeah. So our goal we want to find this ratio, A over B ratio. Okay, yeah. How to do it? We make this ratio or this fraction a variable x. Then we find this x. Yeah, because here A over B, we need to deal with two variables, A variable and a B variable. Yeah, but we only have one equation for two variables. Then it's not easy to find a solution. Yeah. So we want to convert it to a one variable equation. Yeah. We just make this ratio as one variable x. After that variable substitution, we can simplify our ratio equality in this way. Yeah, because here we observe B over A equals 1 over x, the reciprocal of x. So we can get an equation x equals 1 plus 1 over x. This equation only has one variable, and we feel we can solve it easily. Yep, one variable, one equation, should not be too hard to find a solution. Okay, yeah, we can simplify this equation so we get a quadratic equation, x squared equals x plus 1. Yeah, all right. So next, let's try to find a solution. We solve a quadratic equation. There is a formula, right? Quadratic formula. Yeah. For the general case, we have a quadratic formula, ax squared plus bx plus c, but to make sure it is a quadratic equation, we assume a not equal to 0. Otherwise, it's a linear equation. Yeah. And the formula for the solution, two possible solutions. Yeah. Negative b plus or minus square root of b squared minus 4ac. So that's the numerator, and the denominator 2a. Yeah. Here in this question, our a is 1, b is -1, c is -1. So we can plug in these three coefficients into the quadratic formula. So we get two possible numbers, 1 plus or minus √5, then the whole thing over 2. Now, but remember, what is our x? When we assume x, that's the ratio a over b. And a and b, they're the lengths of some line segments. Yeah. A and B must be positive. A over B also positive. That means we only need a positive solution for this equation. So we drop 1 minus √5, because 1 minus √5, it's negative. So we drop the second possible solution. So we keep the first one, x equals 1 plus √5 whole thing over 2. Yeah, so we find that solution. Yeah, but this number, approximately 1.618, yeah, and the people call it golden ratio, and they use the Greek alphabet phi to represent this golden ratio as a notation. Yeah, we know pi, right? Yeah, the meaning of pi, but here golden ratio, another Greek letter phi for it. Yeah. Okay. Yeah. All right. So yeah. So this with the golden ratio notation, then the Fibonacci number can be represented using some magic formula. So why magic? Yeah, because it's quite unusual. We know Fibonacci number is an integer, but the formula representation, you have root 5, you have phi is a number like that, but you put them together, you will get an integer. And it connects to the golden ratio number. So you can see, quite special. Yeah. All right, so here the formula, the question, how to show it? We want to show it is correct, right? How to show it? Okay, yeah. Mathematical induction. Yeah, we will do that next time. Yeah, next time. So mathematical induction, I may just do once. Yeah, so that count binary digits, that one, yeah, I have a chance to save some time. Yeah, so if I skip that part, yeah, I just do mathematical induction for this Fibonacci formula. Yeah, show you. Yeah. All right. Yeah, let me stop here. Yeah. So we finish part D of module 3, but we have another part E. Yeah. Because I add a project session as part of C last time. So we have a part E next time. Yeah. All right. Yeah. So let's complete part D right here.